Welcome to Video Notes 4.1, where we're going to describe the properties of ionic compounds and name and identify monatomic and polyatomic ions. So please read these sections in your book. So after you read those, also look at page 100, read it, and then list 3 properties of table salt, which is sodium chloride, and then answer this question. Okay, do it, put it in your notes. You'll appreciate learning that. Okay, so bonding. One of the things that drives chemical bonding, we believe, is electronegativity differences of atoms, and so attracting bonded electrons. So if there's a very electronegative atom, it pulls the electrons all the way off another atom, and there's a transfer of electrons. So this is the kind of bonding we haven't really talked about properties for yet. So nonmetals are more electronegative than metals. So when these two kinds of elements interact, the metals lose their outer electrons and the nonmetals gain outer electrons. So what kind of properties will you get of compounds when that happens? Well, here's a list of properties that you should get to know, and we'll practice in the lab. But there'll be high bonding energies, which will have or cause high melting points. They'll usually be hard, brittle materials. They'll be electrical and thermal insulators. They'll be non-conductors when they're solid, but when you melt them or dissolve them, they will conduct electricity because they're made of ions. It's a metal and non-metal. So these are things above here that you would see in the lab along with this one. Okay. Those are properties that you could observe. And so here's what kind of atoms are involved, metal and nonmetals, and the metals transfer their electrons to the nonmetals because of the electronegativity difference. Okay, so what does hold an ionic compound together? Well, after the electrons are transferred, the opposite charges keep the ionic compounds together. So the bond is the electrostatic force. All right, so what can we do to see if substance is ionically bonded? Well, we bring down the hammer. So because of what we think the structure of ionic compounds looks like, there's the oppositely charged particles are bonded and packed close together. And so if you hit them with a hammer, then they'll be brittle because you'll be forcing ions with the same charge next to each other. So you could bring down the hammer. All right. Ooh, can't touch this. All right, so another thing you can do is to put them into water. If ionic compounds dissolve in water, many of them will because many are water soluble. Then when they dissolve in water, the water molecules surround each of the ions, positive and negative ions. And so then if you run electric current through there, because of those charged particles' ability to move, then it will conduct electricity. But if you try to do that when they're solid, those charged particles are stuck in place, so it won't conduct electricity. So ionic compounds conduct when solid. Oh, I said when solid. Conduct when dissolved, but not when solid. It's because of the ability of ions to move. That's supposed to be solid. When it's dissolved, the ions can move, and when it's solid, the ions can't move. So charge can move when it's dissolved, but cannot move when it's solid. So why do atoms bond at all? Well, we talk about those valence electrons. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. This is sodium atom. And then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. This is the chlorine atom. And so you can see that sodium has 1 outer electron in its s orbital, and chlorine has 7 outer electrons in its s orbital, s and p orbitals together, third energy level. So if sodium transfers that 1 electron to chlorine, then sodium has a full inner shell in the second energy level, and chlorine has a full outer shell in the third energy level. So transferring that electron makes more stability, more stable when they are ionically bonded. What about lithium and fluorine? Well, here's lithium has 1 outer electron. Here's fluorine with 6 outer, 1 valence electron, 6 valence electrons. Oh, I said 6, but look, 2 plus 5 is 7. Come on, everybody get your act together. Okay, let me get that done. 7 valence electrons. So if lithium transfers one electron to fluorine, lithium becomes positively charged, it's a cation. And fluorine becomes negatively charged, it's an anion, but then they each have a full shell of valence electrons. Okay, so what do we call these ions that form? Please make sure you have an example and a rule in your notes so when you go to look it up, you have it there. So cations are named with the same name as the element has, but you have to put the word ion after it so you know the difference between the ion and the atom. So a potassium ion would be K. The fact that it's an ion is we look in group 1 on the periodic table to find out it has a positive charge, positive 1. Magnesium ion would be symbol Mg, and the fact that it says ion means it has charge, so it's in group 2A, so it's going to have a positive 2 charge. The anions are named like the element, but you change the Ne to IDE. So when you see chloride, you know it came from chlorine, turns into chloride by turning into an ion. So you have a symbol Cl, and then you know it's a negative 1 charge because they're in group 7A, makes negative 1 charge ions. Nitride came from nitrogen, and it's in group 5A, so it doesn't have a negative 3 charge. Okay. All right, let's see what else we can do. Let's figure out what kind of elements form ionic bonds. I think you already know, but when the metals and the nonmetals get together, that's forming that ionic bond. So you can use the periodic table to help you find out what charge it will be. All right, so here's that stair-step line. That's your metals and your nonmetals. And this is group 1, group 2. Group 18 doesn't form ions. They have a full set. And then positive 4, -4, and -3. I'm sorry, I put -3, but it's positive 3 because the cations. Well, so there's aluminum. All right, so remember how we know the charge on the columns? That's what we're going to use to help us decide what ions are for. So sulfur is right under oxygen on the periodic table, so it's going to form a -2 ion. Lithium is going to form a +1 ion because it's a group 1A. Plus. Bromine is, so we have fluorine, chlorine, bromine, but every element in that column is going to form a -1 charged ion. Okay, ion versus not an ion. Ions have charge, okay? So anions are negative, and they come from nonmetals. Cations are positive, and they come from metals, okay? So keep that in mind. Positive cations, negative anions. All right, so what's the difference between an element, a compound, and an ion? Well, you already know elements only have one type of atom. So you can have that or that, and it's still an element because they're all the same type of atom. Compounds have to have 2 or more types of atoms bonded together. So if you have one of those and one of those, and there's a chemical bond, it's a compound. Ions are atoms or groups of atoms with a charge. Okay. So you could have a fluoride ion, or you can have a hydroxide ion. Okay, so this is an atom with a charge. This is a group of atoms with a charge. So make sure you have some of these in your notes, and we'll look at them in class, but just classify these as, oh, this must be an element because it's only got one kind of atom. This is an ion because it's got a charge. And this is a compound because it has 2 or more elements bonded together. Okay, so polyatomic ions, we have to memorize these because we're going to use them so often. And so polyatomic means many, poly means many, atomic means atoms, and then they have a charge on them. So this is a polyatomic ion, right here, because there's 1, 2, 3, 4 total atoms with a charge. This is a polyatomic ion. This is not a polyatomic ion because guess what? No charge. There's no charge. This is not polyatomic because there's only one atom. So they are not. These are not polyatomic ions, and these are polyatomic ions. So put this rule in your notes, and we'll practice it. When we're talking about 8 or ite in polyatomics, it's the number of electrons in the ion. I said electrons. Holy moly! The number of oxygen atoms in the ion. So a polyatomic ion that has more oxygen atoms than the one with the same name that has the ite ending has more oxygen atoms. Okay. If there's more than you ate, then you put the prefix per in it. If there's less than uite, then you put the prefix hypo in it. So let me give you an example, because those might seem a little random. Right? Oh, look, it's Java. Java, enjoying some chicken. Okay, so the name of this polyatomic ion is chlorate. So there's another polyatomic ion called perchlorate. So you hear this chlorate part, but this per means that there's one more oxygen than the chlorate. So then we know it's ClO4 oxygens, because, and the charge stays the same because it's got the per in front of it. Chlorate is still ClO3 negative, because that's what that one is. Chlorite would be ClO2 negative, because the 8 has one more oxygen than the 8. And then hypochlorite, when you see the chlorite part, you know it's got the chlorine and the oxygen, but it's got one less oxygen than the ite, so ClO negative. All right, polyatomic ions. Look at this. It's a 6-way, 6 resonance structures for an ion. How do I know it's an ion? Because if I put all these in brackets, it has a -2 charge. Because look, -1, 2, -1, 2. All of them show a -2 charge. So these resonance structures represent the polyatomic ion sulfate, SO4, -2. Is sulfate. You're going to have to memorize a lot of polyatomic ions, and sometimes it's easier if you picture the structures of them. So we know sulfate has a -2 charge, because if you look at any of these resonance structures, you see 2 negatives, and it's got a sulfur and 4 oxygen. Okay. So one thing I want to point out is these are electrons being shared, and you know that's a covalent bond, but then it has a -2 charge, so that's what makes this an ion. So a polyatomic ion has atoms covalently bonded together, and then there's extra electrons, so that you know it's an ion. So then this whole thing, this whole sulfate, can be attracted to another positive ion. Okay, so here are some structures, 3D structures of polyatomic ions. And so sometimes picturing them is going to help you memorize them. So we'll get on that this week and then for the rest of your chemistry life. Okay, so here's another way, and I'll give you a chart of this. Don't copy it down. I mean, if you want to, it gives you one way to practice. But these are some of the polyatomic ions you're going to have to memorize. So this is the name of the ion. This is the formula. So you could see like the covalently bonded atoms together. And this is the charge of the ion. So you could see that even though these are covalently bonded, they're carrying extra electrons or not enough electrons. So it gives the whole thing a charge. So if you write the whole formula, you need every element, every subscripts tell you how many of each, and you need the charge next to it in order for it to be that ion. Oh, look, there's some more. All right, and look, here we're talking about the 8, sulfate and sulfite, all right, nitrate and nitrite. And so you can see that every time there's an 8 and an ite, the difference is 1 oxygen in the formula. Okay, ionic compounds identification. How do you know you're running into an ionic compound? Well, you're going to see at the beginning of the formula a metal, okay, metal, and at the end of the formula a non-metal. That's one key, but there's all kinds of ions. So if you see at the beginning of the formula a metal and at the end of the formula a polyatomic ion, it's still ionic, okay? And if you see at the beginning of the formula a polyatomic ion, at the end of the formula another polyatomic ion, then guess what? Still ionic. If you see charge on something, it is not an ionic compound, because compounds are neutral, okay? They're neutral overall when you put the ions together. Okay, so I'm going to circle the ionic compounds, metal and non-metal. Yes, metal polyatomic ion. This is an ionic compound. Yes, yes. All right, non-metal, non-metal. This is not ionic. It's covalent. Okay. I look at this and I think non-metal, non-metal. But then if you go back to this list right here, this is a polyatomic ion, and this is a polyatomic ion. So is that. So when I see this polyatomic ion, I'm like, oh yeah, ionic compound, you betcha. Right? Non-metal, non-metal, not polyatomic. Not ionic, because it's covalent. What about this one? Non-metal, non-metal. Oh my gosh, could it be a covalent compound? But look, it's a charge, so it's not an ionic compound because it's a polyatomic ion. And you know it's a polyatomic ion because you see the charge. All right, so let's, I'm going to put in one more thing, Roman metals. When you see a Roman numeral, you're going to find a metal that has more than one charge, and so it has to indicate the charge in the name of the compound. So just make sure you know this is 1, that's 2, that's 3 in Roman. This is 4, that's 5, that's 6 in Roman. That's 7 in Roman, and that's 8 in Roman. So make sure you can read Roman numerals. Read Roman numerals. You'll be happy you can because you'll know what it means. All right. Oh, look, it's an example. This says iron 3 chloride. So what that means is that the element iron in this compound has a positive 3 charge. That's what this means. Okay. And then you see chloride, you should be thinking what we talked about earlier, IDE, so we have chlorine, and then from the periodic table has a negative 1 charge. So when you see a Roman numeral, know your Roman numerals. All right, so to review, memorize your ions. Use a periodic table with periodic table or polyatomic ions. Okay, let's memorize your polys. Give ionic compounds a prop, so know what to recognize to know it's ionic. Cations come first, and anions come second in the compounds when they're ionic. Hey, it's ChemCat. Hi, ChemCat. All right, so I told you to make sure to do this. Put it in your notes. Do it, do it, do it. And then hopefully now you know properties of ionic compounds. You know what monatomic and polyatomic ions are, and you can find their charges. All right.